do objectives and movements. Okay.
Okay, oh geez.
So I have this AI Spark Studio that helps me to get some questions.
Okay.
Share my YouTube live. So these are some of the questions. I hope you can see.
Yes, please.
Yes. You to the wife in a group. So now this one says a 3-meter long rule. Hey, I'm going to be you know. Friends, Microsoft Word now. Microsoft Word really, my dream. Have you learned about the use of motions?
Hello.
Hello. I can hear you.
No, let me just go. That's why.
Oh, Benjamin. Okay.
Yeah.
I play freezy.
No.
I want to bring the thing down. So let's pick our calculator.
Okay, sir. I'll take it back.
Now I say a 3-meter rule. A 3-meter long uniform beam is balanced at its midpoint. A 3-meter long rule. To increase this one. A 3-meter long rule uniform beam is balanced at its midpoint. If a 10 Newton weight is applied, is placed 1 meter for a pivot, what force must be applied at the other end to maintain equilibrium? So solve it. Let me pick my cooler, my laptop cooler. Yes, have you solved it?
Everything.
We used to do it, we just remove anything. The noise has been going into the live stream. Yes, have you solved it? Okay, let me also start solving it. So then, a 3-meter long rule. So okay. From here to here is 3 meter. It's balanced at its midpoint. So it's balanced at its midpoint. If now we don't know the weight. If a 10 Newton weight is placed 1 meter from the pivot, so if this 3 meters, this is 1.5 meters. It's another 1.5 meters. So if a 10 Newton weight is placed 1 meter from the pivot, okay, it's balanced at the midpoint, so it's basically the pivot, right? If a 10 of 1 meter, if 1.5 divided by 2, so let's say 5, so 10 meter weight will be here, 10 newtons will be here. It's placed 1 meter from the pivot. What force must be applied at the other end to maintain the equilibrium? So as the other end will be here, right? What force must be applied to maintain equilibrium? So this is the what force we are talking about. Now since it's balanced in the middle, this weight is not needed because you can't find a moment about the pivot, right? Let's call this pivot P. So this one, there are no upward forces, right? But we know that some of what clockwise because some of anti. So the clockwise will be the 10 because this one moves like a clock. This part, if you are taking this pivot, taking moments about the pivot, so the distance from here to here is 1, and the newtons is 10 newtons. Should be equal to the anti-clockwise from here to here. The anti-clockwise means this one is moving in the opposite direction of a clock, right? So this is anti-clockwise and this one is clockwise, the positive direction of a clock. So the anti-clockwise means the distance from the pivot P to that force, that unknown force, let's call it W. So that's 1.5. So this is 1 times 10 equals 1.5 times W. So 10 over 1.5 equals W. What's the answer? This is 6.6666 newtons. You understand?
Yes, please.
So that, let's go and look at the answer. Question 1.
Thank you.
Number 1A. So exactly A. Number 2. How many of you were able to solve it to get this answer? Were you able to draw the diagram correctly?
No, sir.
Eh?
Actually,
Were your objective so. Number 2. Benikum. But still, Charlie, engineering grinding. A seesaw is 4 meters long.
Right.
Is it?
The solution. Is I want to write the solution.
Oh, sorry.
I say.
Yes.
So I want to learn how to draw the diagram because so that I can easily find the answer. But without the diagram, Charlie, it's not easy.
Okay, so let's look at the diagram again. It says a 3 meter long uniform beam is balanced at its midpoint. So you draw a straight line. Wait, this thing. Let me use a red pen. We draw a straight line from here to here. Right. Oh, on the bars now. I'll draw 3 meter. From here to here, 3 meter. Now 3 meter, because it's balanced in the middle, you put a pivot in the middle. You put a pivot in the middle. The left hand side is 1.5 meters. The right hand side is 1.5 meters. Are you okay?
Yes, please.
And you draw a perpendicular, a vertical downward force, which is the weight. But this time, because the weight is acting on the pivot, you can't find a moment about that pivot because moment is force times perpendicular distance. So you have the force, but there's no distance. So whenever you are finding the moment about a pivot, is 0. So now let's say that if a 10 Newton weight is placed 1 meter from the pivot, so now you can place it at the left hand side or at the right hand side, any of them. So you can place it 10 meter. Now you see we have 1.5. If I divide 1.5 into 3, I'll get 5, 0.5, 0.5, 0.5, right? And I need 1 meter. So 0.5 plus 0.5 will give you 1 meter. So I stand at 1 meter from the pivot. Straight line like this, and draw it downwards. And that becomes your 10 newtons. Are you okay?
Yes, sir.
You can also put it at the other side. But I said that what force must be applied at the other end. So if you draw it here, the other force should be at the other end so that it will keep the ruler in what? Equilibrium. Right? Or if you bring it here, it means you have to put the other force at the other end. Now these are the ends. So all the time draw the ends. Right? So the end here and the end here. You understand? So depending on where you want to put the listing, the other force. Are you okay?
Yes, sir.
Then after that, sum of upward forces equals sum of downward forces. But right here, we don't have any upward force. They didn't ask us to find any reaction. Even if there's a reaction, yes, there's a reaction, but it is insignificant because it's acting at the what? At the pivot. Are you okay? It's acting at the pivot. So the next principle you have to use is the what?
Sum of clockwise is equal to
anti-clockwise. Now what is the clockwise? When you stand at one point on a pivot, look at the forces that are involved. You see that the 10 Newton force, it moves in a clockwise direction. Right? It moves in a clockwise direction. If like you are putting a force on it, it's like a bench with one leg. If you put something down here, if somebody sits here, the bench will move in a clockwise direction. Right? Similarly, this becomes clockwise, and if somebody sits here too, the bench will move in this direction. That makes that one to anti-clockwise.
Okay. Yes, sir.
So let's look at the next one. It says that a seesaw 4 meters long. So it is a seesaw 4 meters long. Sure. Let's drawing straight line on this computer is difficult.
Good morning, sir.
Yeah, good morning, Patrick. How are you?
So it's not Patrick.
Hey, unruly vibes, Benjamin.
Hey.
So, I hope you enjoy your sleep.
Let me like.
What's today?
No.
I just woke up.
It's good. It's a small sacrifice to pay for salvation. I'm quoting Thanos.
We need more sleep.
Yes. Don't worry. Me cry. I need more sleep than you, but Master, I'm also sacrificing for you.
We need energy drink. Yeah.
So this is your 4 meters, right? Everybody, step by step, do what I'm doing. If I do it in your book. Draw a straight line. Give this borders. That becomes the beginning and the end. Write the 4 meters here. Obiaye.
Yes, sir.
Now it says that it's balanced at the center. So the center is here. Hey. Center. It means the weight is at the center. And it's balanced. If okay, if a 30 kilogram child sits at one end, now it's a seesaw, so there's going to be a pivot here, right? Pivot, right? So as a seesaw, the akwalaba bet on one side, akwalaba bet on one side. So if a 30 kilogram child sits at one end, so the child is here. Sits on one end. So 30 kilogram. When you multiply it by the acceleration due to gravity, which is 30, which is 10, it's going to be 30 times 10.
300 newtons.
300 newtons. Right. How far from the center should a 20 kilogram child sit to balance the seesaw? So how far from the center should a 20 kilograms child sit? So 200 newtons. How did we get a 200 newtons? 20 kilogram times 10 meter per second
10 newtons. 10
what's that? 10 meters.
10 this one.
Internal funnel.
10 meters per second square. Okay, let's continue. Right. So now, these are the listing. Now, from here to here is 2 meters. You have to divide by 2. So here's 2 meters. And this one too is also 2 meters. But we don't know the distance from here to here. From here to here, we don't know. So we can put x as the distance. Now, there are no upward forces, right? So you have to taking moments about pivots. About pivots. So sum of clockwise cause sum of anti-clock. Now this one is a very simple problem, right? So I want you guys to learn how to use calculator to do it fast. 200x equals what? 300 by what? 2. Right, so x equals what? 300 times 2 over 200. This and this will cancel. 2 go here 2, so x is 3 meters. Do you understand?
Yes, sir.
This place is clockwise. This place becomes anti-clockwise. And one. And you know the distance. Force times perpendicular distance, 200 times x, 2 meters times 300. Then you are good to go. I hope you're okay.
Yes, sir.
Yes, sir.
Okay, so let's go look at the answer. Number 2. Number 2 is B. B, which is what? 3 meters. Okay, let's go to number 3. A door is 0.8 meters wide and requires a moment of 12 Newton meter to open. What force must be applied at the edge of the door to open it? So let's use a bird's eye view. Right, this is a wall. Right, and this is a door. So the thickness of the door is here, with the handle. Now it says that a door is 0.8 meters wide. So from here to here is what? 0.8. And requires a moment of 12 Newton meter to open the door. Now, what is moment? It's force times perpendicular distance. Right. So if the moment alone is what? 12 Newton meter. What force? And we have the distance at 0.8. What force do we need? So it's 12 over 0.8. You get it?
9.6.
9.6.
15 no.
So it's 15.
15.
Are you Slomulism about so na oh down
Got it.
So it's 15. Hey, but how can 12 divided by 0.8 give you 15?
Mathematics.
0.8 times 12 or times 15. Okay, 0.8 is a fraction.
Yes.
Okay,
8 on 10.
so that's the answer. C. Right, number 3 is C. So now number 4. I hope now you are getting understanding.
Yes.
This one is the force. The force should be here. And let's go to number 4. Manga somewhere number 4 and I'm sure mommy answer now.
Okay, sir.
A mechanic uses 0.5 meter long wrench to apply a force of 40 newtons. What's the moment upon the pivot? This one is easy. Force times distance. And one.
So it's 20.
20. Number 4B.
Yes.
Number 4B. Number 5. A uniform beam 6 meters long is supported at one end. If a 15 Newton weight is suspended 2 meters from the support, what is the moment about the support? This one you may need a diagram, so do it and let's see.
Okay.
Also doing mine. Did you get 100? Number 5 is 100. Did you get 100? Were you able to draw the diagram?
So please, I drew it, but I had two weights. I had two forces.
No,
15 things and the weight. You said it was 15.
yes, the uniform beam. Very good. Even if you have the weight, it said a 50 Newton weight is suspended 2 meters from the support. What is the moment about the support?
But you didn't bring the middle weight.
Yes, I didn't bring it. Because there are no pivots on both sides.
So is it going to be 50 times 2?
Simple. It's like the basic questions. When we started doing the pivots, what were we doing? We were just doing force times perpendicular distance. Right?
Yeah.
So this one is force times perpendicular distance. Even if the weight is there. We don't even know the weight. Right? We don't even know the weight.
Yes.
So they say just find a moment about the pivot. So is this time this, then you go. Or you want to use weight. If you add weight, it will become complicated. Let's say, yes, 3 times weight. So you use clockwise moment and anti-clockwise. All of them anti-clockwise. 3W equals plus 100 equals 0. It won't work. You just want you to find a moment about that pivot. With the force, that force in contact now that you're talking about. I wish we could explain this thing. Okay, number 6. What's the principle of movement? What is the principle of movement? Number 6.
So B, for a system in equilibrium, the sum of clockwise movement equals the sum of counterclockwise movement.
Very good, very good. Please, do you understand? Oh, okay. I did not coffee the tribunal. Any question? That's the counterclockwise. Anticlockwise is the same as counterclockwise. Okay, number 6B. Let's go and check. Yeah, number 6B. Number 7. What is the moment of 100 Newtons force applied to an angle of 30 degrees to a lever 2 meters long? Right, so we have to resolve the force. This one, you may need a little drawing here. Actually, more there, touch a four, Now, are you solving number listing, number 7?
Yes, sir.
I say, what's the moment of 100 Newtons force applied at an angle? So this 100 Newtons. 100 Newtons applied at an angle 30 degrees to a lever. So what do you do? This one is one of the earliest questions we started with the moments. Yes, what's the answer? What's the answer? Two for lemon brown. I don't have so much. Da 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 dee 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 dee. Hey, more sorry. I'm into here. Resolve it perpendicularly, right? In the perpendicular force, so you have to use SOHCAHTOA. Here is 30, 60, right? So, TOA-SOHCAH, now the tree version of SOHCAHTOA, TOA-SOHCAH. So what is this? What you are looking for? So what is F? F is adjacent. 100 is hypotenuse. So cos 60 is adjacent over hypotenuse. 100 cos 60 is the force. So now force times perpendicular distance. 100 cos 60.
50.
Times
50.
Hey, 100 though.
100 cos 60.
That times 2. Times 2
So
meters.
it's 100
Yeah, 100
newtons meter.
meter.
So that's option what C. So number 7, as we saw already, number 7 is what? Number 7 is C. Number 8. If a 60, now were you able to draw the diagram? Were you able to draw the diagram? Were you able to resolve it perpendicularly?
Sir, please, yes.
Okay. Number 8 says a Newton, if a 60 Newton meter moment is required to turn a boat, of what force must be applied? Using 0.75 meter range. So, I mean, you know a boat. Boat and that. Right. Now, I'm a screwdriver. This is a screwdriver. Right. A 16 Newton meter moment is required to turn a boat. What force must be applied? Using 0.75 meter range. So we don't know the force.
18.
So I have C. 80 newtons.
18 newtons.
So 60 over this thing, 60 over 0.7.
Yes.
It should be 85. Oh, how do you get 0.75? Sorry. So 80 newtons. Very good. So number 8. C.
Yeah.
I think this one is enough. Like, I think all these questions here, you can solve it.
Yes.
So let's go and solve some section B questions. Just go to Google and type WAEC e-learning. WAEC e-learning. Then click on this one. All the topics for WASI. You can study it there. That's Nigeria questions. So the categories are there: maths and applied science. You can all the topics: business, accounting, bookkeeping, commerce, economics. So visual arts, food and nutrition. So you can click on mathematics and applied science. If you can't scroll, you can just click here. It will just give you the listing. Mind you, these are Nigeria questions. So further maths, you go to further maths. So all the past questions from 2008 up to 2023.
Okay.
And click on it. Paper 2. This one is always paper 2. So you see how the nature of questions are, and the chief examiner's report. This one is combination. Nigeria questions every day they will bring combination. Number 2 is substitution rule. Right. Number 3, sets. Number 4, circles. Number 5, median. Statistics. Number 6, probability. And you see the solutions too are there. And the chief examiner reported that majority of candidates were able to form correct probabilities, but some candidates, after forming a probability, could not expand correctly. Understand? Then on one more solution. Number 7. This one is forces. I'll drop the link inside the group.
I appreciate.
Me da tumbu sa ba mo nya serious mo nsu ya. There are a lot of websites you can learn from. Forces act on a particle. Find correct to decimal place. This one they didn't draw the diagram. There are 3 forces. They didn't draw the diagram. Number 8. Acceleration. So every day I say that question 7 and 8. Question 7 will be vectors and question 8 will be what? Mechanics. The acceleration of a particle starting from rest, moving at any time t seconds, is given by this. Find the time taken. They didn't draw the question well. It's equations of motions. They didn't draw it well. You come to number 9. Functions. Number 10. Matrices. Find the determinants. I'm solving 3 simultaneous equations, but this one I'm going to use matrix, inverse of a matrix to solve it. I don't want you to use determinants. Sure, no question we about you. And then number 11, graph, linear programming. Number 12. This one is probability.
So is number 11 always 2?
11 and 12 is statistics and probability.
That.
And 12, 13, 14 is this thing. You see, 11, 12, 13. Number 10 is the this thing, pure mass. 10 and 11, 9, 10, 11 is pure mass. 1 to 8 is compulsory. So 9, 10, 11 is pure mass. All the things from Form 1 to Form 2. Then 12, 13 is statistics and probability. A farmer finds out that out of every 100 oranges he harvests, 15 are bad. If he selects 20 oranges from his farm, what's the probability that 3 of them are bad? So this one is conditional binomial probability distribution. It's either they are bad or they are good, right? So for every 100, the 100 becomes the what? The number of trials, and the 15 are bad. So probability of bad is 15 over 100. If he selects 20 oranges. So if 15 are bad, then how many are good? 85. You understand? And binomial probability, it will always highlight on one side of the question and be silent on the other side of the question. So the one that it is highlighting on, that's where the exponent should be checking. You have to be checking the exponent of those ones. So you can see that right here, the exponent is on 3. Okay, so if he selects 20 oranges from his farm, what is the probability that 3 of them are bad? So the total distance is 3. The number of trials is not 100 rather, it's rather 3. The 100 is giving you the probability, the total probability. So you see that when you multiply the exponent, when you add the exponent 3 and 70, you get 20. So 20 combination 3. And what the question is highlighting on is 0.15. That's the bad. The question is highlighting on bad. So your exponent should be on the bad. 3 of them are bad. So exponent 3. In an international market, the demand for phones had a Poisson distribution. What's your Poisson distribution? Find the probability that in a randomly chosen period, the demand is at most 2. Poisson distribution is not in our syllabus, so you can skip that one. This one is the final one. Find their variance. The mean of 4 consecutive numbers is 6. Find their variance. So the mean is 6. How do you find variances? The distance between them, every object and the mean, and find the mean of that situation, right? The mean is 6, right? So the variance is the distance from every element from the mean. Square it and find the mean of that iteration. So this one is this one is this, and find the mean of that iteration too. Putting a formula there, sigma open bracket x minus x bar all square over n. Do you remember the formula for variance? This one you can use calculator. You can use calculator after you solve and get the odds, the x and those stuffs, man. Now the numbers are 3, 5, 7, and 9. Right, you press AC, shift, and start.
1.
Select 4. Then select 3. 3 is for standard deviation. But the relationship between standard deviation and variance is that when you square standard deviation, you get your variance. So that's it. The answer is 5, as we see over here. Let's go to question 14. This one is projectile motion. The movement kakrawa. So that's what I was looking for. A particle is projected at an angle of 42 degrees with initial velocity of 68 meters per second. Calculate to one decimal place the greatest height traveled. This one, you've not done it before. It's not in our syllabus. But when you go to the university, you do it. Those who go and do maths, I beg your pardon. So this question, this one is done. From here, be a check. Particle is projector motion. Daniel, you've done it in physics.
Yes, sir.
Projector motion. The angle here is 40 degrees. 42 degrees. I can't draw the curve smoothly. With a velocity of, so u, initial velocity 68. Calculate the greatest height. The greatest height traveled. So at the greatest height, can you solve it?
U squared over 2G. The U squared over 2G, maximum height.
U squared over
2G.
2G. Yes, it's hey, are you sure it's not GT squared over 2? Isn't not that my equations of motion they're not all
Okay, you use that one.
Okay, let's see if I use your own, if you get it correct. But why are we using that one?
To find the maximum height. Oh.
Okay, let me use your own and see. Okay, I think you're right. That's what the book was also using. So U square 68 over 2G, 2 times 10 meters per second. Right, but we have a sine of 42 over here, sine 42 degrees. And because of the angle here, right, opposite to hypotenuse. That's why you have the half here. It forms a right angle triangle. Right. So sine 42 goes opposite over hypotenuse. Something like that. Then you multiply this by this. This is the initial velocity. It's like a velocity time graph. Are you getting it? So the initial velocity is like 68. This time is 68. Sine 42 over 2. Because it's been a while I saw such questions. It's not in the Ghana syllabus for the E-maths. But it's a physics question. That's a physics student, you should be able to solve it.
Yes, sir.
So that's the solution. H equals U square sine theta square over
2G.
2G. It's actually U square over 2G, but the U square, no, to find the U, this is what the sine theta. I should stop saying this.
So that's also a different formula, which is U squared sine theta squared over 2G, which was applied here.
Okay. Maybe a chair. So where's this thing? Let's look at the moments. And we can call it a day. A uniform beam PQ. PQ. Now, everybody pay attention. You're solving this question. Just don't know how to draw now. A uniform beam PQ.
Say a non-uniform beam.
Hey, thank you. A non-uniform beam PQ of length 15 meters. So this one, if it's not uniform, it doesn't mean that the weight is always at the middle. right?
Yes.
So a weight of 120 newtons rests on a support P and Q. Wow. 120 here. Another 120 here. And weight 120 newtons rests on support. Hey, sorry. Rest horizontally on support. Hey, wait. Let me do it. You have to read the question. A non-uniform beam PQ of length 15 meters and weight 120 newtons rest horizontally on supports P and Q.
So it means the 120 newtons is not at the center, but it's maybe anyway.
It's true. So it rests on supports at the end, P and Q. If the gravity of the beam is 3.5 meters from Q, so it means the gravity now. Listen, is here. It means that the weight is here because weight always acts as gravity. Do you understand?
Yes.
So 3.5. This becomes a 120.
Yes.
And it becomes 3.5. What is 50 minus 3.5? 11.5. So
11.5.
for me to yes, 11.5. Alright, so if the gravity of the beam is 3.5 meters from Q, find the reactions at Q. This is what we are looking for. Wow, the reactions from Q. That means you have to take moment about P because you can't take a moment about Q.
Yes, sir.
Should we use upward forces equals downward forces?
So let's try it and see.
That one will be reactions at Q. And mind you, there will also be another reaction at P. So far as there are pivots involved. The reaction is the force that acts from two surfaces in contact. So let's say this is the reaction at P. Reaction at P. Reaction at Q. So, wait, the upward forces will be downward forces. The fact that they are silent on the reactions at P doesn't mean we should ignore it. So, reactions at P plus reactions at Q gives you 120 newtons. Are we okay? Sum of upward forces. Now, taking moment about P. We can't take moment about Q because Q is the reaction that they say you should look for. So over here, sum of clockwise or sum of anti-clockwise. So if I'm taking clockwise about P, this one will be clockwise. The weight will be clockwise.
Oh.
So
Yes.
this is P. So what's the distance? 11.5. And here is 120 newtons. It should be equal to the reactions at Q. This one will be anti-clock. Q. And what's the distance over there? 1.15 meters.
0.5.
No, it's 50 meters. From P to the reaction
Yeah,
at
50.
Q. So let's multiply. 11.5 times 120 equals 15 times reaction at Q. So what do we get?
1,208.
Oh, my story has started this way.
1.0.
So the final answer is 92.
Eh?
The final answer is 92 newtons.
92.
Yes.
So reactions at Q is 92.
Newton.
92 newtons. Let's go look at their solution and see if it's correct. Yes, 92 newtons. Exactly.
Then,
Yeah.
please, can you go back to the question? I want you to explain something for me also for me.
Okay, I'm listening.
Okay, so you see they said if the gravity of the beam is 3.5 meters from Q, so does it mean that is it the 120 which is the gravity or what?
You see, weight is mass times gravity, right?
Yes.
And the gravity
Yes.
always acts at the center of gravity, where mass is concentrated. So if it's a uniform beam,
Yeah.
and the weight, the mass is spread uniformly throughout the beam, right? But this one, it means that the beam could be something like this. It could be something like this. So it means more of the mass is over here. Right?
Oh, okay.
So that's where the center of gravity will be. Something like a spanner or this thing. Someone in spanner.
Yes, spanner.
Spanner is like this, and the head is here.
Yes.
Right. So what if more of the listing is here, and the mass is concentrated here? It means that's where the center of gravity will be.
Oh, okay.
But something like a ruler. A ruler is a uniform something. The weight is distributed evenly throughout. It can also be like a bottle of water. See, a bottle of water is like this, rectangular like this. What if more of the water is placed here? It means the center of gravity is around this part.
Yes.
So your interscience, you should work here.
Okay.
So that's why we have to relate the weight to that center of gravity. Because weight always acts vertically downwards from the center of gravity. Okay, I think these questions are fine. Now, there's another website I'll teach you to. Just go to Google and write my school NG, then my school NG. It will give you the website. You see, it's also a Nigerian website. You can take advantage. There are a lot of questions there, mathematics. Then.
My school was
NG.
okay, and the first one was 1C e-learning.
WAEC e-learning.
WAEC e-learning.
Then my school NG too. Where you press on it. You see the past questions, all questions: accounting, commerce, government, mathematics, commerce, and additional mathematics or further maths. Yeah. So all types of questions. Why jump? Then BBR by year. So you can select the year 2024. Type of questions, theory, practical, then. And to give you the questions. So you see the questions are there. That's one the answers to are there.
Wow.
Right, trapezium rule with coordinates.
So all questions from Nigeria, right?
Yes, all are Nigerian questions.
Okay.
Ghana for me is serious. They have to create a website to do something like this. I don't know if there's a Ghana website like that. So it gives you all the questions and then the solutions. You see? Now this question, inclined planes. Right. This one we were discussing the last time we went to the school. It says what? A body of mass 40 kilogram is placed on a rough inclined plane. Whenever you hear a rough inclined plane, it means friction will be applied, right? Which makes an angle of 30 degrees with the horizontal. If a force of 420 newtons is applied upwards, parallel to the plane, find the maximum friction that will keep the body in equilibrium and the frictional coefficient. So this is the solution. You draw the diagram. Your friction plus the mg sin theta equals 420. You make the friction the subject. So what's the maximum friction? I'll keep the distance. And that's it. And B, the coefficient of friction. It's also what? The force times the distance. Let me solve it for you. Let's solve it together. But the Ghana was the inclined place has come only once. So. But that doesn't mean that we shouldn't learn it. We should learn it because you can't write them off. Okay. I don't phone them on way. Okay, so let's look at the question. Now, a body of mass 40 kilograms is placed on a rough inclined plane. So this is the inclined plane. 30 degrees. So this is a 40 kilogram. Weight acts vertically downwards. So 40 newtons. Right. Gordon, are you following?
Yes.
So the angle is 30 degrees. Right. Now, the forces that act on an inclined plane, you have weight acting vertically downwards. You have what? Normal reactional force. In this case, because the distance is a rough surface. Now, I say a force of 420 is applied upwards. So there's a force pulling it upwards. 420 newtons. Right. Parallel to the what? Plane. Find the maximum force that will keep maximum frictional force that will keep the body in equilibrium. So now the normal forces are these are the normal forces. This becomes mg sin theta. Right. And this one becomes mg cos theta. Right. Now the friction to come here because friction moves opposite to the what? The force that is acting on it. This is the force that is acting on the object, that is pulling the object upwards. So the friction will act opposite to that force. Are we okay?
Yes, sir.
Yes, sir.
The last time I explained the mg sin theta and mg cos theta. Those who didn't come to the Saturday classes. He said,
Please explain again.
Explain again. Okay, so let me explain for the purpose of YouTube and those who can enjoy later. If you have an angle theta here and you have an object sloping down the inclined plane, these are the forces that act on it. We have weight, which is what? mg. Now, you have your normal reactional force. Your normal reactional force is perpendicular to the surface, right? And this force will be sloping down here, right?
Yes, please.
And it will also be balancing on this side. If it's smooth, friction will be 0. But if it's rough, there will be a frictional element involved. But for it to balance, these are the forces that are involved. And there's another force down acting downwards to the plane, perpendicular to the plane downwards. Right? Now the angle between the force of Newton's weight and that force here is theta. Because when you bring a parallel here, if you bring a force or a line of action parallel to the plane, it forms a right angle triangle here. Right.
Okay.
Now there's also another right angle triangle here. If you join this and this, let me zoom that in. There's another right angle triangle here. Now this line, there's a parallel line here from here to here. It's parallel to this one. So if this right angle triangle, if I'm talking about this right angle triangle, right, the angle over here becomes 90 minus theta. Automatically this one too is 90 degrees. From here to here is 90 degrees. Right, so it makes this angle, this small angle, or theta. Because if everything here is 90, and here is 90 minus theta, that's what I'm talking about. If everything here is 90, and here is 90 minus theta, then automatically here is theta. You understand?
Yes, sir.
And that theta line is parallel to this line of action passing through the object. Are we okay?
Yes, sir.
Now, we are supposed to resolve these forces in terms of what? Mg. That is your weight. Right. So this force, if you are using the angle here, the angle theta here, this force becomes your what? Opposite. And this one becomes your adjacent. Right. So
Yes, sir.
the line is too thick. I've zoomed it too much. Right. So if you are taking that triangle into consideration, if you are taking this triangle into consideration, this triangle, and this is your weight, and a triangle of forces down, and you have your weight as mg, right? And this is 90 degrees, so this is the 90 we are talking about. This is adjacent. So if you are finding adjacent over hypotenuse, the weight is your hypotenuse. Cos theta equals what? Opposite. Because it is adjacent. So if I say this force you don't know the force, let's say it's adjacent over hypotenuse mg. So mg cos theta equals A. So that becomes the force here. This force mg cos theta. And if you want to find the opposite to sine theta equals opposite over what? Hypotenuse. Now mg sine theta equals O. So the force here is what? Mg sine theta. But that force is parallel to this force. Are you getting it?
Yes, sir.
So this becomes mg sine theta. Then this becomes what? Mg cos theta. Are you okay? It's because of the position of the angle here. This theta here. The theta here. So I hope you understand.
So we can say from the what's the name? The Sukatwa that we had the formula.
You said?
It's from the Sukatwa.
Yes, it's from the Sukatwa. Yeah, from the Sukatwa. And the angle involved, if the angle here is the same as the angle between the weight and the line of action here.
Yes, sir.
And the perpendicular inclined plane, the line perpendicular to the inclined plane. When you join this and this, you get a right angle triangle. But it should not be explaining your physics class. They'll just say that, hey, mg sin theta, mg cos theta. But because it's a math class, you have to explain the angles for you to understand. That's why whenever we are doing physics, you need your maths. You have to mind your maths because the maths will give you the logic and the physics will give you the application. Okay, so now that we've gotten it, let's solve it. This one too, because we are talking about forces, they balance each other, right? So R equals what? Mg cos theta. In the question, what are we being asked to find? It says you find the friction, the maximum friction that will keep the body in equilibrium. So we have this and this being equal, and also the forces here. You see, sum of upward forces equals sum of downward forces. Right. Similarly, sum of the forces on the moving in this direction is equal to sum of the forces moving in this direction. Are we okay?
Yes, sir.
In related to the plane,
Yes.
about the plane, the inclined plane, not the vertical. So over here we have what? Mg sine what? 30 plus the frictional force. They are moving in this direction. Should give you 420. Now what is mg? Mg is a weight, 40 sine 30. Sine 30 plus the frictional force equals 420. So just make friction the subject. So the frictional force equals 420 over 40 sine 30. So this will cancel. 4 away 1. 4 away 1. Hey. Umo bi a check calculator name. 420 over 40 sine 30. 21 newtons. Are we okay? Hey. Oh, I made a mistake somewhere. Oh, it should be subtraction rather. Sorry. This should be subtraction, not division. It should be the frictional force was 420 minus 40 sine 30. 40 sine 30 is 20. So 420 minus 20.
400.
But I don't think that's what the book is getting. They're getting 220. They said 10 sine 30. What is the weight of the object? 40 kilogram times 10 meter per second. 400 though. Hey, we made a mistake. The gravity is 10 and the weight is 14 kilograms. So it's supposed to be 400 newtons. Over here.
So 400 sine 30.
400 newtons. So 400 sine 30. That's 200. So this minus 200. 420 minus 200. 220.
220.
Yes, that's it. Now the frictional coefficient, the coefficient of friction. That one, you know that the frictional coefficient is perpendicular. It's proportional to the normal reactional force. So the frictional coefficient is this times R, the normal reactional force. Right. So this is what we are looking for. This is what we are finding. So Fr over reactional force gives you what? The mu. Now what's the Fr? 220 over the reactional force. But the reactional force is also what? mg cos theta. From this equation, sum of upward forces and downward forces over here. So mg cos theta. So that's 220 over 400 cos theta. Cos 30. What will be the answer?
So for 400 cos 30, the 3 forces and
So 0.6, everything becomes 0.63.
So 0.6, everything becomes 0.63.
5. Yes, that's it. So now that we've mastered moments, our next topic will be inclined planes. Inclined planes and other problems. So maybe from tomorrow we'll start working on those ones.
Okay. So there's no unit, right?
And there's no unit, it's a constant.
Okay. Okay, sir.
thank you for
Okay, Charlie. We shall meet again. We shall meet again tomorrow morning, 4 a.m.
Okay, sir.
Tell your people now they have the luxury of watching it on YouTube too.
Oh, okay.
Yes.
It's live on YouTube.
Alright, thank you.
Charlie, guys, we shall meet again. Take care.
Okay, bye.